Alright students, this is page 92 of the notes, example 8.2 and example 8.3. These two examples are designed just to get you used to setting up your hypotheses. Okay, so that's what we're going to do. In example 8.2 it says a car dealer advertises that its new subcompact model gets 47 miles per gallon. You suspect that he's overstated the true mileage. Write a set of hypotheses for a hypothesis test. Draw a diagram and shade the rejection region. So this is to also get you used to visualizing rejection regions in the critical value method of hypothesis testing. So the first thing that you want to do is set up your hypothesis. So you're going to have the null hypothesis, which is H naught, and you're going to have the alternative hypothesis, which is HA. In the null hypothesis, it's always what they're claiming. Okay, so in this example, they are claiming that they get 47 miles per gallon. You can write it out as a sentence, which in non-mathematical applications people often do. However, since we are in statistics and we are in a math course, we're going to use mathematical notation rather than sentences. We're going to say basically that the dealer is claiming 47 miles per gallon by saying mu equals 47, and you can put MPG if you wish. And then our alternative is what you suspect is really going on. Okay, that's how the alternative hypothesis will always work. It's what you suspect is really going on. So we suspect that he has overstated the true mileage, so it's going to be mu and a symbol and 47 MPG. Okay? Everything is the same in the alternative hypothesis as it was in the null hypothesis, with the exception of the symbol. In the null, it's always an equals, and in the alternative, it's either a less than symbol, a greater than symbol, or a not equal to symbol. Okay? So look through the sentence. You suspect that he has overstated the true mileage. That's a key word. When you overstate something, you suspect what is actually true. Well, you suspect that it's actually less than 47, don't you? Since it's less than, it's going to be a left-tailed test. Okay? Because the arrow is pointing left. So when we draw our critical region, we're going to draw it on the left-hand side because the arrow is pointing left. We're going to label it with our critical value, which we'd look up in a table. It's negative because it's on the left-hand side of 0. And we shade the tail left as well, don't we? And we're going to label it our rejection region. And this is for the critical value method of hypothesis testing. If you use the p-value method of hypothesis testing, you don't necessarily have to draw the pictures, but just be aware that this shaded region is the p-value, which you'll discover later on. Let's do example 8.3. A diet club claims that its members lose an average of 4 pounds per week. So I'm going to stop there. That is my null hypothesis. They are claiming 4 pounds a week. Right? A consumer group wants to test the claim because it's suspected that the club is exaggerating effectiveness. So they suspect that it's actually less than that, don't they? These are very similar. This one should go much smoother for you. So that is my null hypothesis and my alternative hypothesis. And again, we're going to have a one-tailed left test. So if we set up your rejection region, you're going to shade the left tail. You would look up a critical value in the Z table, which we'll practice later on, and you would label this your rejection region. Okay? And that's all we do in these two examples on page 92.